video, we're going to look at growth versus decay, and when we would use growth and we would use decay and what that really means in terms of an exponential function. So I am going off of the enVision's Algebra 2 Topic 6.1 Example 4, where they're using a car. But before we jump into that, let's talk about growth. Growth is when the base of your exponential function is greater than 1. So you are adding to the population. Growth would be like a population growth. We see this in different countries. Decay would be something that we see, let's say, in carbon dating, where carbon breaks down X by half through X amount of years. So my base here would be less than 1. And that's why when we look at carbon dating, we look at the half-lives, half being our base or 1/2 being left between 0 and 1. And that's why we see that as a decay. All right, so these two will allow us to know if we're working with some function that's going to infinity or we're working with a function that's going down to some horizontal asymptote. So a car was purchased and the price of the car is $24,000. The value of the car can be modeled by an equation, which is 24 being in the thousands, which means our output is going to be in the thousands, times 0.8 to the x value. And they use x. I would typically use t, but the people in enVision math decided to use x. And so the first part of this is we have to identify, am I working with a growth or a decay? I know just personally from car buying and car reselling, the car value never actually grows. And so we should actually be seeing a decay in our equation. And looking at our base, we do have a decay. So b is less than 1. It is greater than 0. So we are working with a decay. So the function CTION represents a decay. If it represented a growth, you would actually have an awesome car that everybody would want to buy. There are cars who have gone through a decay and then start going through a growth depending on the rarity of the car. But most cars go through a decay and then just kind of bottom out at, about $1,000 to $3,000, maybe even less depending on the brand or type of car. So we do want to look at a decay. Okay, the second thing we want to look at is what was our rate of decay? So we know that this is a decaying function, but what is our rate of decay? Well, remember back with the population, we have the initial amount, I'm going to say just P-O, or peanuts, and then we had 1 plus or 1 minus. Well, in this case, because we are working with a decay, it's 1 minus our rate. So 1 minus my rate had to equal 0.8 so that we could get this 0.8 as our base. Solving for my rate, we get the rate is equal to 0.2. So our rate of decay is 20%. I guess I should put the word is 20% and finish up that sentence. So the rate of decay is 0.2 or 20%. This means that the value of the car decreases by 20% each year, which is not unheard of. Some cars decrease a little bit faster than that, so that's crazy. All right, part C wants us to graph the function on a reasonable domain. Okay, so a reasonable domain is something that we're going to be paying for. So we have 24 times 0.8 x. And when I graph this, move this over a little bit. I'm going to move it over this way just so we can see the decay. And again, a reasonable domain would be, I don't know, we're going to start like here at 24K and then just kind of drop like this. And that's kind of what our graph would look like. I could look at each one of these points, it'll get closer and closer to 0 and go on forever. So what do the y-intercepts and asymptote represent? Well, if I'm looking at the y-intercept, the y-intercept would be the starting value. So y-intercept would represent the initial amount. And the asymptote would mean that we're getting closer and closer to my car not being worth anything, but it will always be worth at least something, even if it's like $10. It'll always be worth something. So will the value of the car, or when will the value of the car be 5,000? So I could go to the graph. I'm actually just going to say 5,000 equals 24 times 0.8x. So this is what we're looking for. I could go to the graph. I could go to when y is equal to 5. Boop, 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 boop. And go down here. And I would find graphically that this is 7. So at year 7, approximately, the car would be worth $5,000. So 7 years after the person owning the car, at year 7, the car will be worth, I don't know why I put care. The car will be worth $5,000. So it has a pretty steep depreciation of this car. Most people do sell their cars at about 7 years or 5 years, so they could get some money off of it. Or after 7 years, it's just kind of worth holding on to it until the repairs start costing more than the car. So using the graph to find the value at which a car would be worth X amount, or finding when the population is an X population, things like that. So here is a great representation on how we can use growth and decay to figure basics of life. Now, the math for car buying and depreciation does go a little bit step further. This is basic exponential growth and decay, but this is a great example of the depreciation of a car. So if you have any questions, please feel free to get a hold of me, and I will catch you in the next video.